Hi, good evening. My name is Stephanie Miele, and welcome to the 25th anniversary Women Dives Hall of Fame interview special. I have the honor and privilege of being able to interview Dr. Shirley Pomponi. It is going to be an amazing interview, and I'm so excited to get started. So let's bring Dr. Shirley Pomponi in. Dr. Shirley Pomponi, how are you?
Hi, Stephanie. I'm well. How are you?
Good, good. Thank you so much for taking the time to be with me tonight and do this interview.
It's my pleasure.
Yeah, so let's kick this off.
Okay.
You have an amazing resume. I was reading through this and I was unsure where to start, but there are so many people that are interested in your trajectory when it comes to career. So, let me ask you this question. How did it all start for you?
Well, it's actually really interesting. And first of all, I apologize to anybody who's heard me talk before because they've probably heard this story ad nauseum. But I always wanted to be a nurse. When my mom was a nurse, I wanted to be a nurse, and I was a good student. I did well in school. And when it came time, when I was graduating from high school, and I had every intention to become a nurse. And at that time, you didn't have to go to college to be a nurse. You just went to nurses training for 3 years. And my mom, who was a nurse, said, you can be a nurse, but you have to go to college first. So then I went to college. I selected a college that had a really good record of placement of its graduates in like medical research, because I figured, well, I want to, at least get some kind of training that'll be applicable to becoming a nurse.
Mhm.
And about halfway through, between my sophomore and junior years, I had the opportunity. This was a Catholic all girls school. So we had nuns teaching us. And the nuns, two nuns, took 9 young women, 19-year-old women, to St. Croix for a marine ecology field course.
Wow.
And that was, I guess, what they call an inflection point. That for me was like, this is what I want to do. So at that point, from that point forward, I decided I wanted to go into marine science. And then my senior year in college, I started applying to grad schools, and that's how it all started.
Wow. Wow. And what a career you've built for yourself. I was looking at this. How and why did you end up at Florida? Did you do your studies in Florida to begin with?
Yeah, well, so I went to grad school at the University of Miami.
Yep.
Now, I grew up in a small town. Where I went to school was a small town. I am not a city girl. So I was in Miami in the 1970s. I'm old. And it was not like Miami is today. It
Yeah.
was it was a dangerous place to be. You couldn't, it was just not a good place to be. And I, not a city person. I hate it. I hated every minute there. So this is where my mom stepped in again.
Yep.
And she never forced me to do anything except two things. One was go to college,
Mhm.
and the other was just stay, because I was miserable in Miami. Hated. And I was at a really good school, the University of Miami Rosenstiel School of
It's
Science. There was,
amazing.
just a growing program at that time. Only 6 of the 100 graduate students were women. So it was, it was an interesting time. But I just hated being in Miami. I liked being at the university, but I hated Miami. And about at Christmas time, or no, actually, it wasn't Christmas time. It was after I finished my first year and went home to New Jersey for the summer, which is unheard of when you're in graduate school. And I said to
Yeah.
my mom, I'm not going back. So I said, I'm not going back. So I worked during the summer, and when it was time to go back, she said, you're going back? I said, no, I'm not going back. She said, no, just try it one more semester. I said, all right. But I don't think, and I had a car I was driving. I don't think she trusted me to drive back to Florida.
Yeah.
So she rode with me. So I
Oh,
made sure that I was there. And then everything clicked. So by that second year, then it all clicked. And I lived in Miami, and I was at the University of Miami from 1971 till about 1979. And that's where I got my master's and PhD in biological oceanography. And I specialized in sponges, but not in, I mean, it wasn't anything I mean, it sort of prepared me for what I was doing, but I was still thinking, I was just marine ecology. I wanted to work in marine science, marine ecology. Um, and then in December of 1980, and I was doing, less, like I focused on sponges. I could
Mhm.
identify sponges there. Around that time, there was a lot of leasing of ocean bottom in the Gulf of Mexico,
Hmm.
and they had to do environmental impact statements.
Yes.
And so they were pulling up a lot of sponges from these dredges that they were doing, and I was helping to identify them. And so it was, something that I learned how to do. It was kind of a fun thing to do. And then in, I guess, November of 1984, I got a phone call from someone at Harbor Branch Oceanographic, and they asked me questions. We understand you know how to identify sponges. Yep, I do. We have some sponges we would like you to identify. Okay, and I went through the whole thing. How many samples do you have? How are they preserved? The same the questions that I go through, and they were like, no, 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 you don't understand. We just started a program in marine natural products drug discovery. So looking
Huh.
for chemicals that are produced by marine plants and invertebrates. We weren't working with, fish or any other vertebrates. And we'd like you to help us organize the collections. I'm like, oh, okay, well, that sounds interesting. And they're like, yeah, and we would like you to go out on a cruise with us. I'm like, oh, this is starting to sound really interesting. So at that time,
Yes.
I was living in State College, Pennsylvania. I had already shoveled snow 3 times.
Yeah.
And I said, well, when do you want to, when's all this going to happen? And they said, sorry for the short notice, but the cruise starts on December 4th. And this was, I mean, less than a week away. I said,
Wow.
send me a ticket. This was, again, long before, like, you could go online, get,
Yeah.
e-tickets and stuff like that. Sent me a ticket. And kind of the rest is history. I had the opportunity to go out to sea, to go on a submersible, to go down and see these amazing sponges that I had only seen from actually drawn, like pictures drawn by sponge taxonomists from, like, the 19th century. I mean, we're talking the 1800s, early 1900s, and they're drawing these beautiful pictures that they could just put together based on, like, fragments of sponge that
Yeah.
they pulled up from dredges. And for me, I was like in heaven. So it was really interesting because I ended up kind of coming full circle and ending up and doing kind of medical research with a marine science background. And I was I was lucky. I happened to be at the right place at the right time with the right expertise and a willingness to step out of my comfort zone. And I did this for about 4 years, commuted back and forth. So I would go out on the expeditions.
Wow.
And finally, by about the fourth year, I said, when are you guys going to offer me a job? And the whole time, I had been, complaining about how much I hated Florida and hated, so they said, we were just waiting for you to say that you were ready to move back to Florida. So
Yeah.
I did. And that's where I've been for my, most of my career.
Wow. So your mom sounds like she was an amazing figure in your trajectory and career path.
Yeah.
What is your fondest memory of your time with her?
Probably, oh my gosh, there's so many, Stephanie. Going shopping with her.
Mhm.
Um, I would say, though, because she passed about 5 years ago, and towards the end of, as she got older, she would come down and visit more and more.
Yeah.
And I'd say probably more recently, like, fond memory was like every Friday we would go out. I'd take her to the hairdresser to get her hair done,
Mhm.
and then we would go out for lunch, and then we would go shopping. So those were the types of things that, that we would do together that I don't really do. I don't go, if I go shopping, I don't go with anybody. I just go by myself. But
Yeah.
I would go with my mom. And I would say the other thing is that she never really, neither one of my parents really forced me, they never had to force me to study or force me to
Mhm.
do anything like that. Um, but she was like strong, but in a very subtle way. And I
Yeah.
remember her saying to me one time, Shirley, you just need to know what it is that you want, and then just go after it. That was it. Just real simple, like these little, tidbits she would drop every now and then.
It's amazing, and you've carried that through your whole career, and that's just special. So, your mom was obviously a figure in helping to shape and push, if you will. Is
Yeah.
there anybody else that you would draw from when it came to career trajectory or just having a mentor? Was there anybody special that you wouldn't mind sharing a little bit about?
Yeah, I think there were a few people. I mean, for sure that the two nuns that taught us biology. I mean, it was a small college, and the two nuns who taught us biology really gave us a very well-rounded education. And once they knew that I was interested in, continuing on in marine science, they really helped me in terms of, I mean, just in terms of, what I really needed to focus on instead of in terms of my studies and so on. So I'd say that Sister Teresa Angela and Sister Anna Catherine were really influential. And then I would say there were other strong women in science who probably don't even realize that they were good mentors to me. So I can think of, say, Rita Colwell, who
Mhm.
was my boss for a short period of time when I was at the University of Maryland. She went on to become the director of the National Science Foundation. She's a very well-known microbiologist, and she also was she probably doesn't even realize that she was such a strong mentor for me, but she was.
That's sweet. I love that. It's the subtleness, like you mentioned with your mom. Sometimes just being there, giving that helping hand that you can do it, it just means the world. And I love that. And it, you're that for me in many ways. I know that I kind of pseudo told you that you're going to be my mentor, but I think that you have just been amazing, not only to me, but I've seen you specifically when it comes to the Women's Harvest Hall of Fame, how welcoming you are, there's always a smile on your face. This resume that I have in front of me is no joke. But the fact that you are so approachable and kind, it just really sets a stage for mentorship. And I love that about you. So I just wanted to say that and
Well,
embarrass you a little
tha
bit.
thank you, I appreciate it. I actually enjoy mentoring students as well, and I think probably I retired about a year ago from Florida Atlantic University, but I'm still very much involved in science, and I still have PhD and master's students at Wageningen University in the Netherlands. I still, interact with my former students, and I mean, I enjoy doing that, and you just never know, um, how you might, and just like I'm sure Rita Caldwell doesn't know that she's a mentor to me,
Mhm.
and I probably don't know that I've been a mentor to others as well. I always say to my kids and my family, it's like when you're in the line at Walgreens, you better be nice because you never know who's going to be standing around there and knowing who you are.
That
And
is very true. That is very true. You be kind to everybody. You never know what somebody's going through and how a kind word will just make their day.
yeah.
So the submersibles that you mentioned, can you talk a little bit about it?
Yeah, I mean, for sure, that's the reason decided to stay
Yeah.
at Harbor Branch because we have the Johnson Sea Link submersibles. Actually, you
Yep.
probably can't see it, but there's a picture of it back there hanging on the wall.
Yeah.
And there were two Johnson Sea Link submersibles. They've been out of commission now for about 13 or 14 years. And they were two chambered, big plexi sphere in the forward chamber. It's about 5 feet in diameter and 5 inches thick, and pilot and scientist sat in the front,
Mhm.
and you got in and out from a hatch. So once you're in, you're in. And then there's an aft chamber that was originally designed as a diver lockout chamber. So the submersibles were originally designed to take divers down to the bottom,
Yeah.
um, about 600 feet, I think. And then divers would go out from the aft chamber and do their work on the bottom. And then as time went on, scientists wanted to go deeper and deeper. And so at that, we had a very strong engineering department, still do,
Mhm.
a strong engineering department at Harbor Branch. And the engineers worked closely with the scientists and the submersible crew to design tools that we could use. So instead of using our hands, there was a really nice manipulator arm that allowed us to collect different types of organisms. We started putting nice cameras on so we could photograph things. And so eventually you could get down to, we got down to about to 3,000 feet. So
Wow.
it's great. To me, that was to be able to go and, know that you're like one of, 4 people seeing that particular organism
Yeah.
or, environment at that particular time. And, it's amazing. And it worked out well for me, both professionally and personally, because that's where I met my husband. He was a
Fun.
chief submersible pilot, manager of the undersea vehicle. So we got to know each other from work, and relationship developed from there.
I love it. That 3,000 feet. Wow.
Yeah.
What emotion comes to mind when I say 3,000 feet in a submersible? What's the first thing?
Um, I'm, I guess just awesome. It's
Yeah.
just awesome because you see something, we saw something different on, every dive. I mean, there are times that you would see things that, no one has ever seen before. We
Yeah.
discovered a lot of new species, and, you could visualize kind of interactions of the different organisms. And, it's just mind blowing, the stuff that you can see. And then, if the trim is just right. And the other things is the habitats are amazing too. So we did a lot of work on steep walls. So
Okay.
places where you couldn't get to, like with, dredges and trawls. So we could work on steep walls with this rocky bottom, which is what we needed to be able to find the benthic, so the bottom dwelling sessile, so they couldn't move, they were stuck to the bottom. These benthic sessile organisms that we were interested in, like sponges and octocorals and ascidians, things like that. And so, sometimes, you just think about it, it's like, you're on a cliff, except instead of
Yeah.
climbing, you're just dropping to the bottom gently and then moving up. And sometimes, depending on how well the currents, if there aren't any currents and the trim on the submersible is just right, and
Mhm.
you have a tremendous submersible pilot, and you can just kind of almost like fly along these cliffs and buttresses and just see the most amazing things.
That must have been gorgeous.
Yeah. So there's a question about the average amount of time we'd be in the sub.
Yes.
It would be we'd be down for about 3.5 hours. So it was really based on how much battery, because these were with, you had batteries. It was
Yeah.
battery operated. It was not tethered to the surface. It was free swimming. And so we would stay down for about 3.5 hours. You could
Yeah.
stay down for longer than that, but we would do a 3.5 hour dive, come back up, offload our samples,
Mhm.
work on our samples. And while we're working on the samples, the sub is charging. And then we would make another dive, probably about maybe 4 hours later. So we typically go in the water around 8 o'clock in the morning, come up around 11:30, and then go back down again around 3:30 or 4, and come up around, 6:37, something like that. And it's a long day because
Yeah.
you're down diving, but then you're working on these samples when you come back up as well. So, but it's pretty exciting. Others who use the submersible, sometimes they'll stay, for 8 hours or even longer. It's just a matter of how deep you are, if you're moving, how long the battery is going to last. So if you're not moving too far along, you're staying, just kind of very small, short transect, you can stay down for a pretty long period of time.
Where did you do some of these dives? Can you give me some
I'd say
locations?
most of the work we did in the Bahamas. I would s we did a lot of work over the years and throughout the entire Bahama chain, but we
Okay.
also worked in, you know, uh, Galapagos,
Wow.
off Panama. The submersible worked over on the, off in the Mediterranean,
Mhm.
in the Eastern Atlantic. So we did a lot of work in the Gulf of Mexico as well. So it was, a lot of work kind of around the southeastern United States, up the southeast, up as far as we worked up as far as probably North Carolina, but the submersible's been all over the world. But for the drug discovery work, that was our focus was mostly southeastern U.S., Gulf of Mexico, um, throughout the Caribbean, all of the Caribbean islands, and then Galapagos, Cocos Island, places like that.
Do you have a favorite spot?
Bahamas, definitely. San
Yeah.
Salvador, Rum Cay, and Conception Island. That kind of like that triangle there, because the bottom was just incredible. These just, buttresses and cliffs, and also you could get in a lee. So if the winds were blowing from one direction, you could get out of that and duck behind one of the other islands. And it was fantastic. It was fantastic for submersible dives, and it was also fantastic for scuba diving as well.
Yeah.
I'd love to
Wow.
get back there. I haven't been back in a while.
Wow. Yeah, it's beautiful there. Um, so the sponges. Tell me about the sponges and what you've discovered about them and how they are used in medical research and purposes.
So I'm going to go back a little bit further with the sponges and how I got interested in
Yes.
sponges. So when I was in grad school, and again, this was the first year where I was like miserable. And one of the classes I took was, this is like all you guys know who are still in school, that yes, you go through these times where you wonder,
Yes.
what am I doing here? Even through your career, sometimes it's
Oh, yeah.
like, what am I doing here?
Mhm.
Um, but I was taking a class in invertebrate systematics, where you learn how to classify organisms.
Mhm.
I had two really outstanding professors. But for a project, we had to select a group of organisms to work on, and we had to do what was called a synonymy. So you had to go back through the history of that organism from when it was first identified and described, and kind of give a kind of like, it's almost like I don't know, genealogy
Yeah.
of that species. And I was, again, miserable, overloaded with classes. And if you did sponges, you only had to do 6. Whereas,
Oh.
like, if you did crustaceans, you had to do 20. I was like, all right, I'll do sponges. So, and I'm not a slacker. I mean, people who know me know I'm not like this, but
No,
it's,
no, of course
man.
not.
So then I realized that the reason that you only had to do 6 is that it was like 10 times as difficult to figure out the names of these sponges, and where, and put the synonymies all together. But that got me hooked on it, and
Yeah.
so then I started, because I was originally going to work on fish for my graduate research, and I switched to sponges then. So and so I and then for my master's, I worked on sponge cell biology and
Mhm.
trying to identify different cellular traits that would help you distinguish one species from another.
Okay.
And then, but for my PhD, I was friends with a bunch of geologists. My friends were geology grad students, and I got interested in sponges that bioerode calcium carbonate substrate. So you call them boring sponges or bioeroding sponges.
Uh-huh.
And I got interested in how they did that, what was the mechanism. So that also got me, interested in kind of cellular, mechanisms for doing things as well. But there's like 10,000 described, this is not an exaggeration, 10,000 described species of sponges, and probably another 10,000 waiting to be described. And so that diversity, that biological diversity, also is kind of the basis for chemical diversity. And the fact that that sponges live attached to the bottom for
Uh-huh.
their, an adult life. I mean, as you know, they they have larvae that are in the
Yep.
water column, but they're attached to the bottom for their adult life. So in order to prevent getting eaten or prevent another organism from growing over top of them,
Mhm.
or to communicate with another individual of the same species when it's time to reproduce, sponges have evolved a very sophisticated chemical communication and defense system over the 600 million plus years that sponges have been on our planet.
Wow.
So it's and these chemicals interact with metabolic pathways that we even as humans have. So even though these are very simple organisms,
Mhm.
I use the word simple, they're just they're just they don't have tissues or organs. They're just cells of
Yeah.
different specialized cell types. But they they've developed these evolved these chemicals that interact with things like, so for example, sponges have water going through them all the time. They're
Mhm.
filtering water, and in that water are viruses, bacteria, fungi, and they need to be able to protect themselves from pathogens, so disease causing organisms. And so it doesn't, it's not too far fetched to think, well, they probably produce antibiotics, some kind of antibiotic. It's not too far fetched to think that when one organism is trying to grow over top of another of the sponge, that sponge is going to produce a chemical that's going to either kill those cells of that other organism or prevent those cells from dividing. And so then you think, okay, well, it's not that far fetched that some of these chemicals might be useful to stop other quickly dividing cells like cancer.
Cancer.
Right. There are other things that these compounds are useful for, like Alzheimer's and malaria. And it's like, well, where does that, how would they be exposed to something like that? Obviously, they're not. But they interact with these metabolic pathways that have been conserved over evolutionary history. And so these very, simple organisms produce these very complex molecules that that we've been able to harness and be able to use for human health applications.
Wow. So during your research, were there any stunning discoveries that you made that really made you think, huh, I didn't really think this was a thing?
It's just like it probably happens to me all the time, and when you think about it, I think it's probably when you see, and I'm part of a team. I'm not the chemist. I'm the biologist, and I'm the
Okay.
sponge biologist. I'm the sponge cell biologist. So one part of a very talented multidisciplinary team that consists of microbiologists, natural products chemists, cancer cell biologists, immunologists. I'm sure I'm forgetting somebody, and other marine biologists all working together.
Yeah.
And it's, I think, probably my the best thing about working at Harbor Branch and in the
Yeah.
drug discovery group is that we all really work together closely as a team and learn so much from each other. And I mean, I will say that, for example, my colleague Dr. Amy Wright, who's a chemist, has learned way more about sponge taxonomy than I've ever learned about
Oh,
chemistry. Um, so, when you see, we get together and we talk about these, and we just did this about 3 weeks ago, about some of these really unique activities that they're
yeah.
finding in the chemicals that come out of these sponges. And you wonder, how did that all happen? Why are they doing it? And what does it do for the sponge? In most cases, we know more about what the chemicals do in human systems than what they're doing for the sponge or the octocoral or the ascidian.
That's fascinating. For those of you that are listening, Florida Atlantic University Harbor Branch is an amazing research institution that is located in Fort Pierce and Florida. We work closely with them, and I have to echo Shirley's sentiments. It is truly amazing to see the work and the cohesive units that are there at the university. And a shout out to all of those folks at FAU. I know they're listening and they're really proud of Shirley. So with the sponge research, has has it parlayed into pharmaceuticals? And if so, what type of pharmaceuticals?
So we have a number of compounds that are what are called like drug leads or drug candidates. And so what happens is we're in the early stages of this in the discovery process where we discover a chemical, the chemists determine and the cancer cell biologists or immunologists determine how that chemical does what it does, what is
Yeah.
its mechanism of action. And then you need to find a partner in drug development, a licensing partner like a pharmaceutical or biotech company who's
Hmm.
willing to license that and develop
Okay.
it. And that's where things get really, falls into what's called like kind of the valley of death, where to get from that discovery stage to where it's actually clinically available. And out of the thousands and thousands of compounds that are found, only a few of them actually make it to the clinic. We had
Wow.
one that was very close, and then there were some problems during the clinical trials.
Hmm.
There's a drug that's available right now. It's not from a spot. Actually, there are a few. Actually, I shouldn't say that. There are a few sponge derived drugs that are available. In fact, one of the it might even be the first marine derived drug that's still on the market is acyclovir. So, like if you use what's it called, Zovirax for like fever blisters and stuff, the active ingredient in that comes from a sponge
Wow.
that grows in just offshore in like wading or snorkeling depths off
Huh.
the coast of Florida. And it was discovered in the 1950s,
Wow.
and then was developed into it. And they're one of the there it's a nuclear they're nucleosides that come from this sponge.
Uh-huh.
And so one is used for herpes infections, and
Hmm.
the other is used for non-Hodgkin's lymphoma. So those were the very first ones. And in fact, that's what led to pharmaceutical companies starting to make an investment in marine
Ah.
natural products, because most of natural products that are developed into drugs are from terrestrial plants or
Okay.
microbes. Think about penicillin, think about aspirin. Aspirin comes from, it was produced by the active ingredient in aspirin is produced by a willow tree. So most of there's a lot of history in terms of natural products being developed into drugs. But Merck, I believe it was Merck, made a huge investment in the mid 1980s in exploring the marine environments in Australia, and that's really what led to a steep rise in exploration efforts. And so then there's another drug called halidin from a
Hmm.
marine sponge that is also used for cancer. And there's one more that I can't think of right now, but if somebody from the drug discovery group is on the chat, write it
Right in.
because I can't remember. And then two more recent ones come from one comes from a cone snail, and
Oh.
it's a drug that's it's called Prialt, Prialt,
Hmm.
and it is 1,000 times more potent than morphine. So it's used as a
Wow.
it's used for chronic pain. And then there's another drug that Harbor Branch scientists, in fact, Dr. Amy Wright was involved identifying the molecular, the molecular configuration of this particular compound, and it's available now. It's a cancer drug called Yondelis. So
Huh.
it came from a sea squirt, a
Oh.
tunicate, again from very shallow water.
Wow.
So yeah, so it's there are a lot of different activities, and and we're finding, and as the tests, or they're called bioassays, become more and more specific, what we're looking for is not something that'll kill any rapidly dividing cell, because that's how you get all these terrible side effects from cancer chemotherapy,
Yeah.
but something that's going to target a specific pathway that's only found in that disease. And so, again, from our group at Harbor Branch, Dr. Esther Guzman has been working on developing some unique biological assays to be able to target these these drugs. And so we can go back into our inventory dating back to 1984 and be able to test these same extracts from
Wow.
sponges and other organisms over and over again.
Wow, you must have an incredible bank of
Yes.
organisms there, and the research that you can parlay into that
Yeah.
is stunning,
It's
and
pretty exciting.
there's
Yeah.
so many of us that have been touched by individuals that that have or have had cancer, and this is truly amazing to be able to have different drugs and treatments so that it doesn't have to be as harsh, and it can be ever changing and more targeted
Yeah.
so that it's more effective.
Yeah.
So it's really amazing, amazing research. Um, I just want to mention to the audience, please feel free to write in questions for Dr. Pomponi, and we can obviously talk about that. But
So somebody actually, let me interrupt because somebody asked a
yeah.
question.
Oh, okay.
How do deep sea sponges contribute to the reef ecosystems and why should we care about them?
Yes.
That's a great question. That's a really great question. Sponges are in coral reef ecosystems one of the key components, really one of the key components. And in fact, as climate, as climate change is happening,
Yes.
temperatures are getting higher.
Yes.
The oceans are becoming more acidic, but we're seeing these effects right now. We're seeing, like, a couple of years ago, we had an extreme heat wave and in the off the coast of Florida and lost many, many corals. Sponges are survivors.
Huh.
And it has been hypothesized and even proposed that maybe that coral reefs may end up kind of transitioning to sponge reefs. I mean, I hope that's not the case. I mean, I'm a big sponge person, but I hope that's not the case. But sponges are key components. They filter a lot of water. It's also been demonstrated that some sponges, some of these ones that actually live in crevices, actually slough off a lot of their cells, kind of like our gastrointestinal tract, like our esophagus, and
Yeah.
they slough off these cells, and those cells go into what's called the carbon loop. So they're used as particulate organic carbon particles for what's typically considered to be kind of a low nutrient environment. So they contribute in terms of the carbon cycling, nitrogen cycling, silica cycling, not only on coral reefs, but in the deep sea as well. And
Wow.
in the deep sea, there are these huge areas that are called sponge gardens or sponge grounds. I mean, we're talking about deep water environments. And
Wow.
and as we do more and more exploration in these deep sea environments, some of these are areas beyond national jurisdiction as well.
Hmm.
We're seeing just big, like, fields of sponges, sometimes just all of one species, sometimes multi-species. And again, they're really contributing to carbon, nitrogen, and silica cycling, and they're very prone to, I mean, they're slow growing organisms down in
Hmm.
that deep water environment. Some of them might be hundreds of years old. And
Wow.
all you need is one deep sea dredge, fishery dredge going through there, and it just wipes them
Wipes
out.
it out.
So there's a lot of concern now about how you can have multiple users of some of these environments and still be able to, to access these environments for a variety of applications. So how can you do deep sea mining and make sure that the say drilling muds and things that are associated
Yeah.
with deep sea mining sediments aren't going to kill some unique ecosystems. And there are approaches that one can take, and I know that there are a lot of smart people who are conservationists and people who are interested in multiple uses of these environments that are tackling these problems right now. So that aquanauta diver is why you should care about them.
Thank you. That was an awesome response. And to your point, there are so many different uses in one area, and I think that if people just tend to, maybe communicate
Right.
and explain what they would like to do in a particular space and have an open communication, it tends to alleviate a lot of the issues that do
Mhm.
happen. So just kind of working together seems to tend to
Yep.
work things out
Yep.
naturally. But
Yep.
yeah, to your point. Um, so talking a little bit about the Women Divers Hall of Fame, and your induction was in the early 2000s.
2003.
You've you've seen it grow,
Yeah.
and I do need to point out to the viewership, Dr. Pomponi has been instrumental in putting together the scholarships and training grants. And when I interviewed, um, in the beginning, I think it was a
Kathy?
$500
Um,
scholarship that this
yeah,
started with, and that was Kathy Wadig mentioned
that's a
that to
weird.
me
Yeah,
back in the beginning,
yeah.
and it's grown to $95,000 this year, correct?
$95,500. It's grown from the first year was 2002 that we
Mhm.
started awarding scholarships and grants. And I think there were four awards for maybe, I'm going to say $5,000. I should know because I was just working on this earlier this afternoon. And now we've grown. This year we have 69 awards for $95,500. And I'm still running the numbers for some of the early years because we weren't using the fancy software that we're using now.
Yeah,
But I just did some rough calculations today for something else we're doing in preparation for our 25th anniversary.
yep,
And we've made over 700 awards since 2002 and close to $1 million, over $900,000. So yeah, it's been great to see it grow. And we have a number of, I mean, we have a lot of people who participate in the
yeah,
scholarship program, and I can't thank our sponsors enough. We have a number of private sponsors. So, Women Divers Hall of Fame members and associates, other private individuals, organizations, foundations that that donate money every year. And in
mhm,
addition to that, we hold fundraisers,
yep,
and people donate to that for the scholarship program. And I would say that probably on an average, about 75% of the funding for annually for the scholarships that we award, about 75% comes from private, individual type donations, individuals, foundations, and so on.
mhm,
And the other 25% comes from our general scholarship fund that we get from donations for our fundraisers. And this year is kind of special because we're awarding an extra 25 $1,000 either basic or advanced dive training grants to celebrate our 25th anniversary.
that's
So, and
awesome.
that's in addition to the other, sponsored awards. This 25 for 25 comes from donations that have been made to our general scholarship fund by people who participate in our fundraisers. And I just can't thank them all enough. They've all made a huge impact on so many young men and women, really.
Yeah, it's
Worldwide. It started out, it started out where most of these awards were in the United States, and we've gone global.
yes, we truly have. I have the opportunity to be able to, review some grants, and it was amazing to see so many applicants from all over the world, and the passion that they have and what they're trying to do, and where this money truly goes is so heartwarming to know that we all play a role in this,
Yeah.
but,
I mean, it
um
it just breaks my heart when I have to send out these decline notices, and this year was really difficult because we had more than twice the number of applicants than we have ever had. We had over 700 applicants, and as these applications were coming in, I was freaking out because it's like, "Oh my god, I'm how am I gonna get reviewers?" We had an army of about 60 reviewers who reviewed all of these applications, more than one time.
Yeah,
So but it's heartbreaking because,
I know.
and I remember saying to all the reviewers, "Don't give everybody nines and tens. Use that full scale." And yet, I said, "Oh my God, how can they all have 100%?" And then I go back and I look and I'm like, "Yeah,
Yep.
that was pretty accurate. Yeah, that was pretty accurate." So, it, you know, it just, we need more sponsors. We need more money,
Yes.
to be able to add more. I'd say our most popular one this year was a new category that we did, dive instructor, dive master, and we had like an overwhelming number of applications for
Wow.
dive master and dive instructor. So it
That's
was
great.
good. It was great. Yeah.
That's
I
great.
think probably for me, my favorite ones though are the ones where learn to dive. And we have
Yes.
and while we only really it's like one person applies for the grant and they're the $1,000 awards, we've had over the years a few times where uh, applicants from I'm going to name it's from Sri Lanka, and there were four of them, and it was a competitive award. And I
Yeah.
said, but it's only $1,000. They said we can get trained for $250, and we don't need gear, we don't need any of that. So we're just getting so much more out of that. With that $1,000, we're getting four people who are certified to dive. So it's super super. It's just really heartwarming to me. And conversely, when I have to send out the decline notices, it
Yeah.
just breaks my heart to do that.
Yeah, it's awesome to read these really passionate individuals wanting to do better, whether it's do better for themselves, do better for their families, do better for science, for the oceans. It's awesome, and we love contributing to it because it's great to see um the action that it generates
Yeah.
where it's exciting. It's paying it forward is what it is. Um, so let me the
So
question
there's
is
another question
oh,
here.
yes.
I see. Khalid Dalawi asked, there we go. I'm interested to learn more about farming sponges for habitat regeneration and medical purposes.
Mm,
What will the return on investment be and some of the challenges associated with such projects? Um, so we've done a little bit of that. And actually one of the drugs that's available commercially, clinically, Halaven, I think it was Halaven. I hope that's the right one. One of them is actually it came from it was discovered and it like a wild natural collection, wild collection. But then they farmed that sponge in New
mm.
Zealand, and so the
Oh,
biomass that they needed to extract the material came from farmed sponges. But in general, what will happen is that a pharmaceutical company doesn't want to really rely on aquaculture or going out and doing wild harvest because it's just too iffy. They
yeah,
want to be able to take that chemical and synthesize it. And so they know they've got a reliable source of the material. Now for habitat, so that and so can it be done? Yes. Has it been done? Yes. And in fact, the material that led into the clinical trials that was used for clinical trials for Yondelis, the anti-cancer drug from the sea squirt, was also based on harvesting that sea squirt from nature, and then using a kind of another method to synthesize the drug eventually, chemically synthesize the drug eventually. Now, for habitat regeneration, though, that's a really interesting question, and we've done some work on that. The typical way to do that that's been done in the past is you take kind of a perfectly healthy sponge, cut it into pieces, and then plant those pieces out into the habitat, and they will regenerate. They will definitely regenerate. The problem is, number one, you're taking perfectly healthy sponges and you're cutting them up, and if you need 50,000 sponges and you're getting 10 slabs out of one sponge, you can do the math. That's a lot of sponges.
it is.
Even if you're just doing 100. So the approach but it's been successful until another harmful algal bloom or an extreme weather event comes and
Yes.
then they get wiped out again. So our approach has been trying to develop a nursery,
Mhm.
land-based nursery, where we could have smaller sponges that and not take the entire natural sponge, but just take a small piece of that and have that grow up to a size that then could be outplanted, but really to maintain a nursery, much like what's being done with corals as
Yeah,
well. So but it's challenging. Just because they can regenerate in nature doesn't necessarily mean they're going to do it in an aquaculture race way.
very
And,
true.
each species responds a little bit, differently. And then thinking about, okay, which ones do I want to, what species are you going to select to do your habitat restoration or regeneration?
Interesting.
The
That's a
approach
great question.
actually the approach that we've used for medical applications is we're working on what's called in vitro or cell culture production. So for the last 30 plus years, my group has been working on developing cell lines that we can use then to produce those compounds in the laboratory in a, in a test tube in a bioreactor. So that's where our research is headed. And we're, it's gotten pretty exciting. I mean, for about, I don't know, 30 years, these darn cells just wouldn't divide. And it was like, okay, I'm going to retire. And then because of my PhD student came in and said, we're using these same two sponges all the time. Why don't we try something else? Because we have a biobank of
Yeah.
cryopreserved living sponge cells from about, we have about 10,000 vials of those cells from about
Wow.
250 species, a couple hundred species. And she said, let's try something else. And so she tried another species that I would have never, ever, ever, ever selected as our model. And lo and behold, the cells divided.
Mm.
And then I didn't retire.
Yeah.
Still too much stuff to do.
Yeah.
I retire for another 5 years. So
Yeah. You gotta act when it's hot.
yeah,
So,
exactly.
wow. Let's see. Are there any other questions that have popped up? I'm not sure.
Somebody said, how can you follow my research? So I'm awful about web pages and stuff. So you could go onto the Harbor Branch, the FAU Harbor Branch website, and it tells a little bit about what mostly what other people are doing. I'm terrible about that. I'm also involved though in another project right now called with the European Union. It's called Project Blues, BLUES, and you can just Google that, and that'll talk a lot about the research that I'm currently involved in at Wageningen University in the Netherlands.
Awesome. Awesome. Yeah, the research is fascinating. And FAU Harbor Branch, they do have an amazing website and they do all sorts of educational talks. So anybody interested in what Dr. Bomponi is doing and or what the university is doing can follow them there. They're fantastic.
Yeah, and there's we have an ocean science. I say we. I'm still part of it.
Yeah. Well,
Ocean
yeah.
science lecture series
Yes.
during the winter. It's every Wednesday at 4 o'clock, but it's also online. And I think it's not. I don't think it's next week. I think it might be. It's either next week or week after next on Wednesday. Dr. Amy Wright, is going to be actually talking about the really fascinating research that's been done over the years to discover novel chemicals with human health applications. And she's an outstanding speaker. So I would just, again, just Google Ocean Science Lecture Series or Harbor Branch Lecture Series, and you'll see it. And then you can just register it it's free, and you can just log in and see it online if you're not in the Fort Pierce, Vero Beach area.
Yeah, it's fascinating. I've attended those in person and they are truly mind-blowing.
Yeah.
The knowledge that is in that room is fascinating. So anybody that's interested in the scholarships and applying for them, can you remind us when do applications open again?
Yes, the applications will open. So we have like a kind of some new scholarships and grants every year.
Mhm.
So check our website. So it's WDHOF, Women Divers Hall of Fame. So that acronym, WDHOF.org,
Mhm.
around the middle of August. And that's when all of our new, I mean, you can go on now and see the types of
Yeah.
scholarships and training grants that we offered this year. And there'll be a press release out pretty soon about if it hasn't gone out already, about the awardees this year. But around the middle of August, we'll have we'll post all the new opportunities, and then the scholarship application period opens on September 1st. It's only open for a couple of months, closes on October 31st. It's all done online. And we improve it a little bit each year. We tweak it a little bit each year, but we've been using that system now for a few years and it works out pretty well. So,
Great.
yep.
And like, Shirley and I had mentioned, there are tens of thousands of dollars that are available for scholarships. And, I think I saw a little message pop up. I guess, Shirley, you're never gonna retire at this point.
Well, I do spend a lot of time. I think the retirement part has kind of given me more time to work on the scholarship
Yeah,
program, so I find that I'm doing a lot more on that as
great.
well. So I enjoy it. It's a labor of love, and as I said, we have an army of volunteers who help in every way possible with
Yeah.
that, from helping with, from sponsoring, from reviewing applications, from publicity, the PR on
Mhm.
it, from all aspects of administration, management, publicity, sponsorship is really. Yeah, I mean, I'm. It's not. I always get the credit for it, but it's really an army of individuals.
It's true. It does take an army, but having an amazing leader is always, special.
Thanks, Stephanie.
So
Appreciate that.
I want to say thank you for taking the time to be with us tonight. It's the evening here where we are. It's about 7 o'clock Eastern Standard Time. But this podcast will be available on YouTube. You'll be able to find it on the What Off social channels, the YouTube channels, the Scuba Diving International channels, so you can kind of listen again because there are so many amazing nuggets of information that Shirley has shared with us this evening. So, Shirley, thank you. And
My pleasure.
um, I'm excited to be a part of the Women Divers Hall of Fame and their initiatives and visions. And I want to wish everybody a good evening. And next month, I have the opportunity to interview Erica Lopez and her labor of love when it comes to Malpelo and what she's doing to help protect the marine park there. So we get a chance to interview her.
She's very
But
dynamic and exciting, and
oh,
she's one of our new members too. So you'll
yes,
just
she
love,
is
you'll
awesome.
love it.
I'm excited. I'm excited. So good evening, everybody, and have a good night.